Hello guys, welcome back to Tronic Synergy, where we do fun stuff all day, all time. We are still in our series of making the 8-bit logic unit, which will be doing 8 different logic operations, meaning that all those 8 inputs or all those 8 operations will be passing through a multiplexer, where we'll be choosing which logic operation that we want. If we want like X, if we want X OR, we'll be placing this code in our select line, then the multiplexer will be showing you the output of that X OR in this logic gate you can see up here. Okay, so last time we did X NOR gate and we gave it the code 101 in our select line, and today we are going to do a not A. So simply this for this just simple not operation. Not operation is just inverting the input. Let's say A was 0, then the output will be 1. If A was 1, then the output will be 0. It's just inverting those input, and it has only 2 possible ways because the NOT gate, you can see it only has 1 input and 1 output, so you cannot have four different possible ways. It only has two configurations, either on or off. So if A is off, you get a 1 in the output. If A was on, you get a 0 in the output. So for that operation, we have given it the code 110, and if you check, this in binary is represents 6. This 6 in binary 110. So meaning that we have 6, 7. 7, there's the last one. 7 will be looking like 111. That will be the last one, and it will be not B. Then we'll be done making our 8x1 logic unit. So you can see if that there is in the multiplexer, because we say that these integrated circuits contain two 4x1 multiplexers, and the first 4x1, the inputs were like this. It contained AND gate, OR gate, NAND, and NOR. The other multiplexer which we connected, if you can remember, we connected using the enable pins of those multiplexers to make it an 8x1, because a single multiplexer has 4, so if we add them, we just make 8, and it has one single output. So for the other multiplexer, the inputs are X OR, X NOR, not A, and then finally we will do not B, and we'll be done making the 8x1 multiplex logic unit. So we have given it the code 110 for the not A. So we are going to place this code in the select line 110, and immediately you can see the LED is on. So we have said that it's just going to check. It has only 2 possible configuration. If A is off, it's going to be on. So let's check. A is off. This is the one that's this is the one representing A, and this will be B. This other one will be B. So this is A, this is B. So since A is off, you can see it's on because we are inverting. If A was to be on, then this will turn off. So let's do that. If we turn this on, then the output goes off because we are inverting. We are just checking the inverter. So if this is on, this is off. If this is off, this is on. So let's turn it off and check. Sorry, it's quite, yeah. If it's off, this turns back on. So that's basically basically the operation that we have given the K2, given the code 110 in our select. So next time we are going to do not B, and then we'll be done making the 8x1 logic unit. So I hope you have been coming along and getting the concept that we are doing here. I hope it's not too hard. I hope I'm not going too fast. If I'm going too fast, please try to rewind with the video, and you'll check it later. So that's basically what I wanted you to see today. So next time not B, and then I will finally do all operations, because all operations have different codes. We have AND with 000, OR with 001, NAND with 010, NOR with 011, XOR with 100, XNOR with 101. Then our recent one today, not A, having the code 110. So the reason as why I'm putting not A and not B as inputs in our multiplexer, because sometimes in let's say in an ALU, having maybe a 4x1 ALU or a 2x1 ALU, if you have added A plus B, then it has given you the output. Then maybe you wanted to know what was A initially and what was B initially. So initially you can check what was A. Since we don't have a buffer, maybe you didn't have a buffer to check what was A, you can use a NOT gate. So if NOT gate is 0, then definitely the input was 1. If the NOT gate output was 1, then definitely the input was 0. So it's always nice and it's always helpful to put not A, not B, just to check the state of your inputs. Yes, just like that. So thank you very much guys for watching. Please subscribe to Tronics Energy, where we do fun stuff all day, all time. Hope to see you next time. Bye.